Problem number 2 here, again, the very first thing we're going to do, the thing at the very top of our flowchart, says to factor out a greatest common factor if there is one. And so I notice that here I have a 1 as a coefficient, so I'm not going to have anything in common with the numbers, but I do have at least a single m in both of these. So I'm going to divide both of these by m and say that m is my greatest common factor. From there, I'm going to say what I have left, and I have m raised to the 4th power and minus 81. So now I want to remember those. We could go ahead and make ourselves a note like I did the last time. We won't wait till the end this time, that this is a greatest common factor. Now I want to go ahead and look at my flowchart to see what we do next. I am going to notice that this is a monomial factor. Remember, it's just a single term, and so I won't be able to factor that anymore. So I'm focusing in on this m to the 4th power minus 81. And when I have two terms, remember it was m to the 4th power minus 81. So I want to look at two terms, and the operation between them was subtraction. It was a minus sign. So I want to be able to determine if I have perfect squares, perfect cubes, or neither. Well, I have an m to the 4th power, and so m to the 4th power would be a perfect square, because I could multiply m squared times m squared, so m squared times itself, and I get m to the 4th power. 81 is also the perfect square of 9, so I do have subtraction and two perfect squares. So I'm going to use difference of squares to factor. Remember that difference of squares says that if we have something that is in this form, in our case it's an m squared and an 81, I'm going to take the square root of that m to the 4th power to get an m squared here, and take the square root of 81 to get a 9 here. So let's go to our notes and put that in. Back over here in my notes, I want to go ahead and just bring along the m. I'm going to break the m to the 4th minus 81 into two pieces based on the difference of two squares. So that says that we take the square root of the thing that's squared. That's going to give me an m squared that I write at the front of each of these. The square root of 81 is 9, and so that goes in the back. One of these gets a plus sign and one gets a minus sign. Now we already decided that m was a monomial term, so we can't factor it anymore. But we need to look at the other two factors, m squared plus 9 and m squared minus 9. So notice that m squared is another perfect square. 9 is the perfect square of 3. But we need to take a closer look at these plus and minus signs. Right, back over here, we have two terms. Our first term that we were looking at was m squared plus 9. So our operation is addition. So this is saying either they need to be perfect cubes or they are not perfect cubes. Well, we have perfect squares, but not perfect cubes. So they are not perfect cubes, so the m squared plus 9 will not be factorable. And we'll make ourselves a note in our notes to remind us of that. Looking at the other term, m squared minus 9, our operation is subtraction. Both terms are perfect squares, so we will use difference of squares once again in order to factor m squared minus 9. Looking at the notes here, I'm going to go ahead and circle this term and just simply say can't factor, because we can't factor that anymore. It's not a difference of two squares. It's a sum of two squares, but remember there's no such thing as factoring that. But we can factor m squared minus 9. So what we're going to do is go ahead and bring down the m. We know that we're done with it. We know that we are done with the m squared plus 9, but I am going to break m squared minus 9 into m and a 3, because the square root of 9 is 3. One gets a plus sign and one gets a minus sign. All right, so we have used difference of two squares twice. So let's make a note. Difference of two squares here and difference of two squares here. Now we need to decide if we are done. M, we already decided, was done. It's a monomial factor. We cannot factor this one. M plus 3 and M minus 3 are both linear, and so those are factored as much as they can be factored. We can go ahead and box this as a final answer.